Hello, how you doing? Have you heard the term self-supervised learning and you're not quite sure you know exactly what this is? Well, if so, then watch along with me for the next few minutes and I will quickly get you up to speed. Okay, let's get started. So what is self-supervised learning? Well, self-supervised learning is a machine learning approach where models learn to generate labels from the input data itself, eliminating the need for manually labeled data sets. It leverages large amounts of unlabeled data, which is more readily available as compared to labeled data. In simple terms, self-supervised learning allows models to learn from data without needing human-created labels, making it a powerful tool in AI. So why should you care about self-supervised learning? Well, imagine training a model with vast amounts of data without the hassle of manually creating labels and still achieving high accuracy. This approach not only reduces the dependency on labeled data, but often results in models that generalize better across different tasks. Essentially, self-supervised learning is a game changer, allowing AI systems to learn more efficiently and effectively. So how does self-supervised learning create its pseudo-labels? Well, it involves designing pretext tasks, which are artificial tasks that help the model learn useful representations, such as predicting missing parts of data or solving puzzles. These tasks enable the model to understand complex patterns and relationships within the data, enhancing its learning capabilities. To put it simply, self-supervised learning uses clever tricks to teach models from the data itself, making them smarter and more adaptable. So how exactly does self-supervised learning generate pseudo-labels? Here in this simple text-based example, imagine the input with the sentence, "The cat sat on the blank." The generated label, in this case, is the missing word, in this example, Matt. In this example, the label is created by hiding part of the input. Here's a second computer vision example. Imagine an input involving an image that is rotated. The generated label would be derived by the prediction of the rotation angle, or whatever transformations needed to match the image back to the original. In this example, the label is the transformation metadata. Self-supervised learning generates labels by hiding, transforming, or splitting the data, then train the model to recover, predict, or match the missing part. So how is self-supervised learning used in training large language models? Well, training LLMs involves both self-supervised learning as well as other learning techniques. LLMs use mostly self-supervised learning during the pre-training phase, but they often use supervised learning or reinforcement learning later in the training process. During pre-training, when LLMs are trained using self-supervised learning, the LLM learns to predict the next word. Self-supervised learning enables a model to understand language patterns and context. In layman's terms, self-supervised learning helps language models become better at understanding and generating human-like text. So what are the advantages and challenges? Well, the main advantage is a significant reduction in the need for labeled data, allowing for the use of vast data sets, often resulting in better generalization. However, designing effective pretext tasks and ensuring that the learned representations are useful for downstream tasks can be complex and requires careful consideration. Simply put, while self-supervised learning is powerful, it requires thoughtful design to ensure models learn effectively. Okay, so let me know what you think of self-supervised learning. Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching.